Hello, today we're going to talk about bonding and we're going to discuss two types of bonding, which is ionic bond or ionic bonding or covalent bonding. Today we primarily will be talking about ionic bonds, and the next time we will discuss covalent bonding. But now for now, you need to have the main idea what is the bonds uh, are. So I gave you an example in my first video that bonding are a kind of force that holds atoms or ions together, which makes this compound more stable compared to the single atoms or ions. So and we already discussed what is the difference between ions and atoms. So that's why a bond which is formed out of ions, let's say we have two types of ions, sodium plus cation of sodium and chloride anion, and together they form ionic compounds. And covalent bonding, we will be talking about covalent bonding the next time. The covalent bonding is their bonds which is creates with sharing valence electrons between non-metals atoms. So ionic compound again. So needs to be metal. N plus means any type of metal cation and non-metal, which have to be negatively charged, so Nn. Or instead of metal cation, it can be ammonia cation, NH4 plus. And covalent bonding is formed between non-metal and non-metal. Okay. Just remind you, but you already know this, octet rule. Elements will gain or lose electrons in attempt to achieve a stable valence octet, which noble gases have. For example, why actually sodium becomes positively charged and it has 1 plus charge, or why, let's say, magnesium has 2 positive charge. The main idea is to become more stable, and we have to look to the closest noble gas, which is close to sodium and which is close to magnesium. So magnesium has number 12 and sodium has number 11, and the closest noble gas atom for them is neon. Neon, let me write it here. So neon has atomic number is 10, so that means that it has 10 electrons outside of its nucleus and 2 electron shells. And its electron configuration will be 1s2, 2s2, 2p6, which gives us 8 electrons on its outer shell. So when out shell is completed, so that means that this atom is stable. And I'm just repeating that noble gases, the only elements that exist as single atoms. They do not form compounds like regular helium, neon, and argon. No compounds are known for them. Okay, so and the way for sodium to become more stable or close to the neon electron configuration is to lose its valence electron. I will start with its formula. So 11. As an atom, it has electron configuration 1s2, 2s2, 2p6, and 3s1. This is its valence electron, right? So, but we can see this part completely like neon has. So these core electrons, the same amount, the same configuration like neon has, one of the noble gases. So, and the way to become more stable for sodium is to lose its valence electron. And when it loses it, it becomes stable with electron configuration like this with 10 electrons. That means that now it's not an atom because atom is neutral and now it's positively charged. That means that now it becomes an ion, and positively charged ion called cations. So this is sodium cation. And about magnesium, the same. So for magnesium, when it's neutral, so 12 electrons, 1s2, 2s2, 2p6, 3s2, and you can see there are two valence electrons for magnesium on its outer shell. And when it loses it, it has the same core, the same amount of core electrons, the same like neon has. So that's why it forms a very stable cation of magnesium with electron configuration 1s2, 2s2, 2p6. Okay, and you can predict that if aluminum has 13 electrons and stable configuration would be for 10 electrons, so the stable cation for aluminum will be 3 positive. Yes, it's correct, and when it's 3 positive, it has the same electronic configuration as sodium cation or magnesium cation have already. So, okay. So these are metal properties. When they form ionic compound, usually to become more stable, they lose electrons. Okay, but for non-metals, it's opposite. To become more stable, they need to gain electrons, and let's repeat it again. So let's talk about fluorine, uh, oxygen, and let's say nitrogen. Okay, fluorine, oxygen, and nitrogen. So let's start with fluorine. Fluorine atomic number is 9, atomic number of oxygen is 8, and the atomic number of nitrogen is 7, and the closest, the nearest noble gas for them is the same. It's neon with atomic number is 10. That means that neon has 10 electrons. But fluorine, when its atom has only 9 electrons, what does it need to become more stable? Gain 1 electron. Yes, correct. And when it gain 1 electron, it becomes more stable. It becomes an ion, anion, negatively charged particle with 10 electrons, and electron configuration like neon has 1s2, 2s2, 2p6. Or for oxygen, the same. When its atom, it has 8 electrons because it has atomic number is 8. And to become more stable, like neon, it has to gain 2 electrons, correct? And when it gains 2 electrons, it becomes anion, negatively charged particle. C, 2 electrons gives us a 2 negative charge. the same atomic number and 10 electrons outside the nucleus and the same electronic configuration. So, and for nitrogen too, so when it's atom, it has 7 electrons, and it needs to gain 3 to become more stable. So nitrogen 7, but its charge when it's anion, its charge will be 3 negative, and the amount of electrons will be the same. 10 electrons. So two ways for metals and non-metals to become more stable, but when they form compound together, I mean metals and non-metals, metals, they forms ions, cations, positively charged ions, and anions, negatively charged ions. And after they become ions, they attracted to each other. Okay, when we have compound which is formed out of non-metals, that will mean that there is no ionic bond there. There will be a covalent bond, and covalent bond is a bond formed with sharing valence electrons between two non-metal atoms. But you see, there is a term, electronegativity. Electronegativity is the ability of an atom to draw bonding electrons to itself. What does that mean? That means that if a nonmetal has more electronegativity, that the attraction of its nucleus for electrons, not only for its electrons, but for another electrons, will be more than for another atom, and these sharing electrons will be closer to this atom with more electronegativity. And you can see here I drawn a formula which shows us then that if we have a compound out of hydrogen and chlorine, the sharing electrons here will be closer to chlorine. Why? Because electronegativity of chlorine is more than electronegativity of hydrogen. There is a chart, electronegativity of the element, and you can see elements located at the same places at the periodic tables. And I will give you a link of this chart. And these numbers like 2.20, 0.98, these are electronegativity. So, and we can compare actually electronegativity. For chlorine it is 3.16, and for hydrogen is 2.20. That means that, of course, electronegativity of chlorine is more present than electronegativity of hydrogen. That's why sharing electrons in this compound stay closer to chlorine. But by the way, the next class, the next time, we will discuss this part more and more. Just for the first sign, you need to understand the tendency, right? So as you can see, during the period from left to the right, you can see that electronegativity is increasing, correct? For each period. Let's say for period number 2, from lithium to neon, electronegativity is increasing. Actually, excluded, noble gases are excluded because for 3 of them, for helium, neon, and argon, there are no existing compound known, but for krypton and xenon still have a few. But anyway, we can think that noble gases are so noble that they tend do not form any compounds. And you can see that for each period, electronegativity is increasing from the smallest number to the biggest one, and for every period is still the same. And out of all elements, the element with the highest electronegativity is fluorine. So if it has bond with every nonmetal, it will be that nonmetal who will gain who will attract shared electrons more, who will put them closer to its nucleus. And the less electronegativity is for these elements. Number 87, it's francium. So it's metal. So there are general rule, metals have less level of electronegativity than nonmetals. And out of nonmetals, there are three the most electronegative nonmetals known. Fluorine, the first one, then oxygen, then nitrogen, and chlorine. So just let me correct myself. So fluorine, oxygen, chlorine, then nitrogen. So four the most electronegative nonmetals. But anyway, we will talk about that the next time more and more closer. So, ionic bond. Ionic bond occur when the valence electrons of atoms of metal are transferred to atoms of nonmetals. And after electrons are transferred, there are no atoms anymore. There are ions. And after ions are formed, strong electrostatic forces exist between atoms. So metal, or let's say cations, metal becomes cations, n plus, I mean, there it could be 1 plus, 2 plus, 3 plus, and so on. And non-metals tends to form anions and minus. And after, they just attract to each other. And covalent bonds form when atoms of non-metals share valence electron. Okay, so as I told you, only noble gases exist as single atoms. Others elements exist in a compound. It can be compound or it can be elements, and it can have molecular structure or ionic structure. So for some elements, you have to memorize that they exist as diatomic molecules, like a hydrogen 8,2. And you can see to show the structure of its molecular, I need to put its symbol H, hydrogen, and use subscript which shows us the number of elements in this molecule. Okay, so H2 means that molecule of hydrogen has two atoms of hydrogen. So nitrogen N2, oxygen O2. That oxygen which we use for breathing is O2. Fluorine F2. Chlorine Cl2, bromine Br2, and iodine I2. Okay, there are other types of molecules. They can have more than two atoms, like H2O, water, and this formula shows us this that molecule of water consists of two hydrogen atoms and one oxygen atom. And you can tell me why it's one, no number here. Yes, when it's no number, that means we have only one oxygen atom here. For ammonia, and you can see it's drawn here, so 1N and 1, 2, 3H, and you can do this with me. So we will have N, nitrogen, and H, how many? I will use subscript 3. For carbon dioxide, this is the gas which we outbreathe. I mean, when we breathe in oxygen and breathe out carbon dioxide. So its formula will be CO2. One carbon, I will not need to put any one here, and O2 means two oxygen. And methane, it's a gas which we use for cooking in our kitchen, let's say. So it has one carbon, so carbon, no one here, and 1, 2, 3, 4, H4. Okay, so these are molecules too, and you can see that when we're talking about molecules, there are no metals there, only non-metals. Okay, so for ions, we were talking about the way atoms become more stable by forming ions, and when atom becomes an ion, it's monoatomic ion, like for example sodium positive, or let's say fluorine becomes fluorine negative, or sulfur becomes sulfur 2 negative. So these ions are monoatomic because they are formed out of only one atom. Okay, but there are big amount of polyatomic ions, and I already showed you polyatomic ions when we did lab. So polyatomic ions, let me give you some example. It can be like NO3 negative, or PO4 3 negative, or SO4 2 negative. So polyatomic means that they're built out of more than one atom. For example, NO3 negative is built out of one nitrogen and 3 oxygen, and all these 3 atoms has one more electron. Okay, that's why it's negative. So it's nitrate. So PO4 3 negative. These polyatomic ions has 1 phosphorus and 4 oxygen, and its charge in total 3 negative. So it's phosphorus. Phosphate. And this one is one sulfur and 4 oxygen, and its charge to negative. It's sulfate. Okay, and you already know that when you need to name monoatomic anion, you need to change its ending, like fluorine. Let's say fluorine when it's atom, but when it's negatively charged, it will be fluoride. So you change these 3 letters on these letters, okay? But you have to memorize names of polyatomic ions. They will be given for you. Okay, so let's do this assignment. So the first one, you need to circle molecules. So to circle molecules, you need to find molecules where only non-metals are. So, and where there are subscripts. So, like P4. P4 is a moleculus. It shows us that moleculus of phosphorus has 4 phosphorus atom inside. Okay. CO2, two non-metals. Yes, it's moleculus. K, like potassium, it's not moleculus because it's metal atom. Nitrogen, it's not metal, but it's only a single atom, no subscripts. Subscript here, I'm sorry, that's why it's not moleculus. KOH, sodium hydroxide, it's not moleculus anyway because of sodium. Sodium oxide, K2O, it's not moleculus too because of sodium. N2, yes, it's nitrogen gas. CO, yes, it's carbon monoxide, yes. Iron, it's metal, it's not moleculus. P2O5, yes, it's phosphorus 5 oxide. It's molecular because it has two non-metals there. Silicon, it's non-metal, yes, but it's not molecular because it's only one atom shown here. And Cl2, yes, it's molecular too. And in addition, H2, boron, no, CH4, and neon, no. Okay. So when you need to choose molecules, which you choose non-metals, and plus subscript. Okay, when you need to circle ions, you need to remember that ions have a charge. So a P3 negative, it's an ion. K, sodium, no charge, it's atom. Iron 3 plus, it's ion. P2O5, no charge. It's not ion. P4, not ion, no charge. K plus has charge. Iron, no charge. PO4, 3 negative, has charge. CO2, no charge. KOH, no charge. SO3, no charge. Silicon, no charge. Neon, no charge. SO4, 2 negative, it has charge. OH negative, it has charge. CO3, 2 negative, it has charge. So I circled charged particle, and charged particle are ions. So the next one, circle diatomic molecules. Diatomic means we need to circle molecules with 2 atoms inside. So P4 not diatomic. O2, yes, it is diatomic. N2, yes, it is diatomic. Sodium 2, it's not diatomic, it's diatomic, but it's not molecular because of sodium, because of metal. Okay, iodine 2, yes. Fluorine 2, yes. It's an atom. C2, yes, it's molecular. It's atom, molecular, atom, molecular, and molecular. Okay, diatomic. Circle polyatomic ions, not polyatomic monatomic ions, polyatomic ions, not polyatomic, not ions, not ions, not polyatomic ions, not polyatomic ions, polyatomic ions, not ions, no charge, not ions, no charge, polyatomic ions, not ions, any charge, polyatomic ions, polyatomic ions, polyatomic ions, not polyatomic ions. Okay, so How anion are being formed? Anion being formed by gaining additional amount of electrons. So you need to memorize octet rules, right? So 8 electrons on valence shell, on its outer shell, is the way to become more stable. So, for example, and you know, it's use dot structure where valence electron is shown as a dots here. So for nitrogen is an element of group number 5. It has 4 valence electrons. And to become more stable with 8 electrons on its outer shell, it needs to gain 3 electrons here. So when it gain 3 electrons, so it becomes nitride ion. Nitride ion, you can call it like this, and nitride ion means nitrogen 3 negative. And I already showed you this rule. So to define this amount of electrons, you need to number of group minus 8, and that will give us the number of gaining electron. Number of gaining electron. Okay, so for oxygen, element of group 6, the way to become more stable is the way to gain 2 electrons. And after it gain, it becomes oxide anion. For fluorine, the way to become more stable, to gain 1 electron, and fluoride become fluoride ion. Okay, so oxygen 2 negative, fluoride negative. You can write fluoride negative or fluoride 1 negative. It's the same, no mistake here. So cations. So metals have small amount of valence electrons, so and it's easier for them to become stable to lose electrons than to gain additional amount of electrons. That's why they tend to form cations to become more stable. So sodium has 1 valence electron. That's why 1 dot is here, because it's group number 1A. And when it loses 1 electron, it becomes sodium cation, and you can call it, you can name it sodium ion or sodium cation. It's still the same, sodium cation, the same. So magnesium cation or magnesium 2 positive, still the same way to name this compound. Okay, let's do concept checking. So we need to fill the table for potassium, number of protons, and you know where to find some help. You need to put periodic table in front of you, and I will use this electronegativity chart. It will give me information which I needed. So because I will need atomic numbers and number of group and period, that's all I need, and it is shown here anyway. So potassium. So potassium, let's find potassium here, and you can see it's 1, 2, 3, 4, period number 4 and group number 1A. So and atomic number is 19. That means that number of protons is 19. Number of electrons is 19 too. Why? Because in neutral atom, number of protons and number of electrons are equal to each other. Lewis structure. To draw Lewis structure, I need to memorize I need to remember what is the number of valence electron for sodium. It's group number 1A. That means that it has only one valence electron. So Lewis structure will be like this. Number of valence electrons. So 1 because of group number 1A. What is easier, gain or lose electrons? And it's metal. And let's say we can write down it here. For group number 1A to 3A, easier to lose for group number 5A, 7A, easier to gain. So it's group number 1A. That means that it's easier to lose. And what kind of ion formed when potassium lose electron? It can lose only valence electrons, so when it lose one, it will have one positive charge. I think it's you understand more now than at the beginning. Let's do another one. So calcium. Jump here. Atomic number is 2. Group number is 2A and period number 4. So 20. Number of protons because of atomic number. Number of electrons, 22. Lewis structure, 2 electrons, 1, 2. Why 2? Because, oh, I'm sorry. I am sorry. 1, 2. And number of valence electrons, 2. What is easier, gain or lose? Group number 2A, easier to lose. Ion formed, when it loses 2, it will become calcium 2 positive cation. Okay, for aluminum. Let's jump here. Aluminum, you can see 13, and you know 1, 2, 3A group number. So 13 protons, 13 electrons, Lewis dot structure, aluminum, 1, 2, 3. Number of valence electrons, 3. What is easier, gain or lose? It's the member of 3A group, easier to lose. Ion formed, when it loses 3 electrons, it becomes aluminum 3 positive. Phosphorus. It's 15 atomic number and group number 1, 2, 3, 4, 5, and it's not metal. So 15 protons, 15 electrons, Lewis dot structure. 1, 2, 3, 4, 5. And then number of valence electrons the same as group number 5, which is easier. And you can see 5A easier to gain. Ion form. When it gains, how many electron does phosphorus need? 8 minus group number minus 8. So 5 minus 8 gives us 3 negative. So ion formed phosphorus 3 negative. Okay, so it is gaining the amount of electrons to have 8 outer shell electrons. Okay, sulfur. For sulfur, here is sulfur 16. It's atomic number 16, group number 6A. So 16 Lewis dot structure. 1, 2, 3, 4, 5, 6. Number of valence electrons, 6. What is easier? Again, you see 6A out of 5, A and 7A. So it's easier to gain, it's non-metal. And ion formed, the same. So 6 minus 8 gives us as 2 negative. It's all 2 negative, I'm sorry. 2 negative, of course, yeah. And for chlorine, atomic number of chlorine is 17. 17, 17. Group number 7A, that means that 7 valence electrons. 7, easier to gain, and when it gain, needed to have 8, that means it will become chloride anion, negative, or 1 negative. Why does the magnesium atom become more stable when it loses 2 electrons? So, and you know the answer. So when magnesium atom has 12 electrons, right? And when it loses 2 electrons, minus 2 electrons, it becomes magnesium 2 positive with 10 electrons, the same amount like neon, as neon. 10 electrons. So by losing electrons, it becomes more stable with electron configuration like neon has. Why does the phosphorus atom become more stable when it gains 3 electrons? Because when it gains 3 electrons, it becomes more stable with 15. When it gains 3, it will have 18 electrons like argon. Why does the magnesium atom become positively charged ion when it loses electrons? Let's do this. So for magnesium atom, it has the same amount of protons and the same amount of electrons. So, and this gives us neutral atom, right? So, but it's when it loses electrons, it loses 2 actually, the same amount of protons, and when it loses electrons, it only have 10 electrons, and 12 protons has plus 12 charge, and 10 electrons has minus 10 charge, and the sum is 2 positive. That's why it's cation with 2 positive charge. What is the answer? When does the magnesium become positive? Why does it become positively charged? Because the amount of electrons less than amount of protons for magnesium cation, okay? Why does the phosphorus atom become negatively charged ion when it gains electron? Let's do the same. So when it's an atom, it has 15 protons and 15 electrons and the same charge, so they balance each other. But when it gains electrons, so the same amount of protons, 15 protons, but 18 electrons. So plus 15 will be the charge for 15 protons, and minus 18 will be the charge for 18 electrons, and the sum will be 3 negative. So we can see that the number of protons will be less than the number of electrons because phosphorus gaining electrons, okay? So the next one, what is the symbol and charge for the following ions having? So 3 protons and 2 electrons. So protons gives us atomic number. So 3 means 3 lithium. So lithium, 3 protons, but 2 electrons. So I will write it down. So 3 protons and 2 electrons. And you know, 3 plus and 2 negative gives us plus 1. So that means that this particle will be lithium cation with positively charged, with positive charge. 12 protons and 10 electrons. So 12 protons gives us atomic number 12. Go to the periodic table. 12 is magnesium. So magnesium 12, its atomic number, 12 protons, and 10 electrons. So you can see that the number of electrons less than number of protons by 2. So 2 positive will be the charge of its cation. 7 protons. 7 atomic number is fair for nitrogen. So nitrogen 7. 7 protons and 10 electrons. You can see the amount of electrons more than the amount of protons, and if you summarize you will have 3 negative charge, so it's nitride ion. Okay, 9 protons. Jump here, 9. Let's find 9. 9 is the atomic number of fluorine. So fluorine, 9 protons and 10 electrons. You can see electrons more than protons. That gives us a negative charge. 11 protons gives us sodium with atomic number 11. Sodium 11, 11 protons and 10 electrons. Number of protons more than number of electrons, plus positive. Okay, 13 protons. 13 is the atomic number of aluminum. So aluminum 13, 13 protons and 10 electrons. So the number of electrons less than number of protons, that gives us ions charge 3 positive. Okay, the next one. When sodium reacts with chlorine, it forms the ionic compound sodium fluoride. Draw the Lewis dot structure for the sodium and the chlorine atoms. Use arrows to show the transfer of electrons between the two atoms and draw the Lewis dot structure of the ions formed. So let's do this together. So sodium chloride. So I'm going to draw sodium. Sodium. Let me. Something is happening. It's not allowing me to. Okay, let's do this. So sodium. Sodium is from group number 1A. That means that it has only one valence electron. And I will show this one electron with one dot in Lewis dot structure. And chlorine gives us I'm sorry. So chlorine has 7 valence electrons because it's an element from 7A group. So when a sodium atom meets a chlorine atom, what is happening here? So sodium loses his valence electron, and chlorine gains addition electron, and after they becomes ions. So sodium has no electrons on its valence shell, right? And chloride, now, as you can see, I am calling it chloride, not chlorine. It has 1, 2, 3, 4, 5, 6, 7, 8 electrons, and now it's negatively charged. And I tried to show you that these electrons only belongs to chloride, not for sodium. And after they becomes opposite charged ions, they attracted to each other, and between sodium cation and chloride anion there is an ionic bond, very strong one. So the next one, consider ionic compound aluminum bromide. So we need 2 aluminum, right? Bromide, and you can see IDE, but the same at the beginning, brom. So aluminum and this symbol BR. So aluminum, group number 3A, that means it has 1, 2, 3 valence electrons, and bromide 1, 2, 3, 4, 5, 6, 7 electrons. And you can see that aluminum has 1, 2, 3 valence electrons, but bromide, one atom of bromine needs only one additional electron. But aluminum can lose 3. That means that aluminum needs more bromine atoms to become happy. So 1 and 1 more. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And these electrons, let's take another color. So these electrons goes here, 1, 2, and 3. Can you see this? And after, let's do here, they become ions. So aluminum 3 positive because it loses 3 electrons, and bromide 1, 2, 3, 4, 5, 6, 7, 8 negatively charged, but 3 times. The next one. So how to making formulas of ionic compound. So to making formulas of ionic compound, you need to know the charges of each ion. And just remember that ionic compound by itself neutral. So for example, let's do some together, and you will become more clear how to do this. So we have ionic compound which is formed with aluminum 3 plus and sulfide 2 negative ions. So I will write it down. Let me do this. Okay, aluminum. Aluminum. Something happened. Okay. Aluminum. Great. Aluminum 3 plus. Okay, let's see. Variables. Free head. Okay. Aluminum 3 plus and sulfide 2 negative. And the way how to write this formula correctly, you need to put these charges cross to each element. So 2 I'm going to put it here and 3 here. For example, how will you think about this? So if we have one aluminum, it gives us 3 positive charge. So and I will draw this like 1, 2, 3 classes here, right? But one sulfur anion or sulfide anion gives us 2 negative, so 2 negative. But all compound needs to become neutral, needs to be neutral. So to make it neutral, we need to add more aluminum here. 1, 2, 3. So that gives us 6 plus positive charge, right? And we need to add 2 more sulfurs that gives us 6 negative charge, and you can see 6 positive here and 6 negative here gives us neutral. And let's do another one. So calcium 2 positive and nitrogen 3 negative. And you can pause my video and do it by yourself and then check it with me. So 3 goes here and 2 goes here. That gives us 3 multiplied by 2 gives us 6 positive here, and 3 negative multiplied by 2 gives us 6 negative. And if we add 6 plus to 6 negative gives us 0. That means that we are right, we did it correctly. So this ionic compound is neutral. So aluminum chloride, aluminum 3 plus, chloride 3 negative. It's easy. So for aluminum it's 1, 2, 3, but for chloride it's only 1 minus, and you know you need to have the equal amount of minuses and pluses, so the equal amount of negative charges and positive charges. That means that you need to add 2 more, right? 2 more chloride. So you can write it like this. It's not 100% correct, but it can give you a picture how we are thinking about that. So 1, 2, 3 chloride ions gives us three minuses, and you can see that 3 pluses here and 3 minuses here. It's equal, it's 0, so it's neutral. But now we need to write it in the correct way. So aluminum 3 plus and chloride negative 3 times. I am using this subscript, okay? So sodium and nitrite. So sodium has a positive charge plus, and nitrite has, oh, something happened. I don't know what to do. Let's do this, and then I will fix it. So 3 negative. 1 sodium has plus, 1 plus. 1 nitrogen, 1, 2, 3. But you know, it has to be neutral, so we need to add more sodium. We have 1, but we need 2 more. That gives us 3 in total. So sodium, 3 nitrogen. Okay, let's go on. So next compound, aluminum 3 plus and CrO4, it's chromate anion. So aluminum 3 plus and chromate CrO4 2 negative. And this is a polyatomic ion. So, and the same. So 3 plus means that aluminum can lose 3 electrons, but chromate needs to gain only 2 electrons. And the way to become it neutral, to make it neutral, put 2 here. This 2 goes here, and this 3 goes here. But you see, when we have polyatomic ions, we need to use parentheses here. So there, if I rewrite it, it will be aluminum 2, CrO4, 2 negative. Okay, another one. This is actually ammonia cation. NH4, it's polyatomic cation, NH4 plus, and CrO4 2 negative. And you can see this is 1, this is 2. So 2 goes here and 1 goes here. When it's 1, we don't need to use parentheses. So aluminum 3 plus and N3 negative. Aluminum 3 plus and N3 negative. The same amount of positive and negative charges, so they equal each other. That means that we don't need to use any subscript here, and it's neutral. The next one, aluminum 3 plus and PO4 3 negative, and you can see the same amount plus, 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 3 plus here, and 3 negative, minus, 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 the same amount of positive and negative charge. So we don't need to use any subscripts here. So magnesium 2 plus and CO3 2 negative. It's carbonate anion. So, and you can see charges are equal to each other. You're good. You don't need to put any numbers here, additional numbers here. NH4 plus, NH4 plus, and OH minus. The same situation, so the same equal amount of charges, so they balance each other. It's neutral by itself. Magnesium 2 plus, OH negative, and this is different. So 2 plus 1 2 here, and OH only 1 minus here. We need one more, and how do we have it? Parenthesis and 2 times. Okay, so chromium 3 plus and OH negative. So you can see 1, 2, 3 positive charges here, but if we have only one hydroxide ion, we have only one negative charge, but we need 3 negative charges because it's the rule, the ionic compound, the whole ionic compound needs to be neutral. So the way is to put it 3 times to have 3 OH negative ions here. So SN4 plus and O2 negative. So you can see 1, 2, 3, 4 positive charges here and only 2 negative charges here. That means that we need to have two oxygen. But see, we don't use parentheses here because this is not polyatomic ion, it's monoatomic ion. So lithium plus and NO3 negative nitrate. So the charges are equal. You don't need to use any subscript. So aluminum 3 plus and NO3 negative, and you can see 3 pluses, 3 positive, and only 1 negative here. You need to use it 3 times. Okay, so sodium plus or H negative charges are equal. You don't need to use any parentheses here. So the next one, you need to indicate cations and anion for the following ionic compounds. So usually cations, or not usually, at 100% of cases, cations are located at the beginning of the formula. So cations, I'm going to write them down. So cations, 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 cations. Cations, cation, cation, and cation. Okay, and anion are at the end, so I will use another color. These are cations, anions. I'm sorry, anions. Okay,